It's all yours.
Great, thanks, Rob. So I'd just like to thank Eric and Rowan for making this event possible, and the earlier speakers who I was just confessing to Jason made me feel quite inadequate about the way I am sort of managing Keynote and making it available for others to use. So I'd like to address three of the questions that sort of frame this whole event. And I'm going to draw a little bit on philosophy of science, and then I'm just going to draw on a comment an anonymous reviewer made to me 2 years ago to address these questions. So here they are. The first one is, do we get overexcited about technology so that we don't make it useful for us? I'm going to draw on the work of Peter Galison, who's a philosopher of science here, and I invited him to join us actually. He had an event in Chicago to try to answer this question. He talks a lot about the role of experimentation and instrumentation in physics, and I'm going to try and translate some of his ideas about change in science into archaeology to see if we can answer the question, does our engagement with technology, is it sort of superficial or substantial? So the second question that brings us here is how can we encourage a more meaningful engagement with technology? And I'm going to draw on the work of Imre Lakatos, who may be familiar to you, a Hungarian philosopher of science who has this concept of a research program. And I'll use some of those ideas and some bibliometric research that I've done to try and make a case about how we can do this, where we should look for the most productive implementation of technology. And then the third question about how can we embrace it in a really transformative way, and how can we create an environment where technology will diffuse and sort of touch every archaeologist and really change the way everything is done. I will draw on this anonymous peer reviewer that made a really interesting comment that I think you'll also find quite interesting as well. And it's in this third part that I will also discuss what I've been doing about reproducible research in particular, and share with you what I think is some very specific kind of recommendations about how we can do that. Okay, so Peter Galison, a philosopher of science, well known for his account of modern physics, and he argues for the importance of scientific instrumentation in what is called image and logic, and that's going to be my kind of motivating framework for this question. He's talking about the idea of a tool-driven revolution. So his work kind of contrasts with Thomas Kuhn, who I'm sure you're aware of, the idea of a paradigm shift in ideas, the revolutionary ideas, and causing the overthrow of old ideas. And Galison says, well, maybe it's not really so much about ideas being so revolutionary, but tooling and instrumentation that leads to huge shifts. So the question is, these shiny things, do they get us into trouble and ruin us eventually, or can they really bring us up and make us better researchers? So are we being distracted by the shiny stuff or not? So Galison, I'm just going to give you a really short account of how he tells the story of changes in physics, and then I'll try to sort of bridge that over to what we're up to in archaeology. So this is an observatory in Scotland, the Ben Nevis Observatory, where physicists went up to look at clouds. So they had to take a trip up to the observatory and spend some time there to study cloud formations, study weather patterns, and atmospheric effects. And there's a famous physicist, Charles Wilson, who went up there, and he was, I guess he got a little tired of the travel and invented this little machine which would enable him to create tiny little clouds in this little chamber in his laboratory back in the city. So this invention of the cloud chamber, Galison argues, is kind of a major step. This is an important tool that has driven a kind of revolution in making observations about atmospheric effects. And incidentally, Wilson made observations that he could see the tracks of atomic particles moving through the condensation. So he was creating trying to study clouds, and that was kind of a revolution in sort of the studies of nuclear particles. And this was around 1912, and he developed this chamber, started photographing the tracks that he was observing. You can see alpha and beta particles here, and these instruments people just went crazy about them. They're mass-produced, very popular in laboratories around Europe. And many new nuclear particles were discovered through the use of this cloud chamber. So it got physicists off the mountaintops and onto their benches using these things. And Wilson won the Nobel Prize in 1927. So that's a fairly significant kind of tool that has driven a revolution in physics. Another one along here, this is a 4.5 cyclotron. So the cloud chamber is quite useful for seeing particles move along, but they put in a little radioactive, a big piece of radioactive material, and particles come out of that. But they quickly became dissatisfied with how slow these particles move. They wanted to get them really fast so they could make them crash into each other and find new particles at higher energies. So this machine was developed that you apply electric current and it sort of speeds the particles up in a sort of spiral-like fashion. And so this became very popular to get very high energy. And then a kind of like arms race developed among a bunch of American universities here in Berkeley and Wisconsin to develop bigger and bigger particle accelerators. This is a 27-inch 1931, 60-inch 1940. And finally by 1954, this is a 6 million volt machine, 10,000-ton magnet, the Beavertron in Berkeley. It's been, all of these, none of these exist anymore, I don't think. But you can see rapidly these instruments are becoming like a big deal. We see, obviously they're increasing in size, but along with that, Peter Galison remarks about how there's also kind of major sociological and economic changes in physics. So it's not just the sort of boutique craftsperson creating their instrument on the bench and then using it. Now there are teams of engineers over in other buildings, physicists over in these buildings, and they don't talk to each other so much to get these instruments together. So the physicist is now quite removed from the craft of the instrumentation. And there are also a sort of third group of people who are, they were nearly all women, who were observing the tracks that were being made through these clouds and writing them down so that they then could be measured. So Galison says it's not actually the tremendous increase in scale or the industrialization and sort of mechanization and compartmentalization of jobs in physics. He says that's not really what is the transformative thing. He says it's the shift from working with the data as an image, so working with a photograph or direct observation of these tracks through the condensate or the emulsions, but it's the introduction of sort of logic processing and taking the measurements with an instrument that is not directly with your eye. So these are very elaborate apparatuses for doing the image work, looking at photos, like tracing the photos, or looking directly at the tracks. And then this is an early Geiger counter. That really is what he thinks is transformative, where these instrumentations stop being a sort of visual thing to get the data out, and people are just instead getting a sort of statistical readout. They're getting a sort of set of blips, which they no longer see, but they can sort of count and quantify and work with. So it's this shift to logic is really important, according to Galison, because it allows huge scaling up. You can just insert a lot of these sensors into one of these machines, and then you can make statistical arguments with much larger amounts of data, rather than what they used to call the golden event, where someone would see a track of something unusual and say, we have a golden event, we've got a new particle. And then hundreds of other people around the world would try to work that golden event. Now they work on a sort of on a statistical scale, where they have all this information coming in directly to sensors in a logical fashion rather than a visual fashion. So this is kind of this image logic thing, where we have cloud chambers, nuclear emulsion, these kind of technologies that appear that are primarily visual, people sort of sketching things and observing directly with their naked eye. And then on the other hand, much of that is replaced by this logic tradition where it's sort of countered by instrumentation, and the output is largely statistical rather than visual or artistic. So this is the key case study for Peter Galison's work, but there are many other areas of sort of scientific development that he discusses in his book, and a couple of things like the steam engine and the related technology of steam came well before we had sort of ideas about thermodynamics, and telegraphy and telephony came before we had a lot of well-developed information theory. So a lot of the tooling instrumentation appears before the sort of theory that helps us to understand it. And there's several other nice examples about people using radio telescopes that were salvaged after the Second World War and sort of pointing out at the sky, and then discovering all this cosmic radio sources that then sort of led to radio astronomy and so on. And understanding of how plants convert carbon dioxide into sugar just comes from sort of what seems to be sort of toying with radioactive tracer chemistry and things like that. So from several sciences we can see new tools appear, and then a big shift or revolution in sort of how things are done and thought about in those sciences occurs. So, and this leads Galison to the idea that maybe it's the tool-driven revolution that is a more significant idea than a kind of idea or paradigm shifting. So I've done in order to sort of extend his idea a bit and maybe translate it over to archaeology, I've done a bit of text mining. So for example, this is the journal Biometrica, which is a very prominent sort of biostatistics, applied statistics journal. And what we've got here is the complete text, full text of research articles from 1901, and I think that's up to 2012. Every 5 years, I just looked at the most frequently appearing words in the text there. And maybe you can see on this sort of, here's a laser pointer. Right, so, oh, it doesn't, maybe the angle is too shallow. Anyway, on this sort of earlier side, there's a lot of use of the word of correlation, population and distribution, and then we see as the word frequencies pick up, this is the volume of articles in the journal is increasing, the word model is appearing there. And I think what we're seeing amongst these biostatisticians is their availability of cheap computing power. Oh, thanks very much. Thank you. Right here, so talking about distribution and correlation, that's what a lot of these articles are about. And then we see that being replaced by ideas about modeling. And so I think what we're seeing is cheap computing power and software that's easy for these people to use. It doesn't require them to work in an assembly-style language, so they can implement these things that are quite tedious to do by hand or to do with the sort of slow computer. So another example. So I think that we see the role of cheap high-scale computing as an important tool in the change in what people are talking about in biostatistics. So here's the proceedings of the Philosophical Transactions of Royal Society Review, which is basically a biology journal. And we see, I think, a similar kind of shift here. This is from the 1940s to the 1990s. Every 5 years, the top words in all of full text. Cell, issue, tissue, structure of growth. So macrostructure is really occupying a lot of interest here. And then we see protein kind of as a new idea that becomes much more popular. I think what we're seeing is developments in molecular methods and sequencing technology becoming accessible and cheap, and a lot of biologists are getting into that. And that's shifting their focus and what they're writing about. So what about archaeology? How can we sort of use this concept of tool-driven revolution in this way of perhaps mining the text about publications to see what tools might have driven revolution? Or is everything just a kind of shiny, flashy thing that doesn't really leave much of an impact on what we do? So I've taken a look at the journal American Antiquity, which is, as many of you know, is kind of flagship journal for archaeology, going back from 1935 through to, I think, 2009 on the end there. And it's, I think, fairly nice career pattern. There's sort of earlier articles, pottery, type, mound, culture. There's a lot of talk about pottery, and then suddenly date pops up here. There's a little bit of mention, I think, of radiocarbon down here in the 60s. At a time you can imagine it's just been developed in the lab in the 50s, and people might be saying, like, what about the amazing potential of radiocarbon dating? Like, just wait until it becomes widely available. And then here in the 70s, suddenly it is something that you can get. You can send off your sample to some sort of industrial laboratory type facility and pay the appropriate sum and get your statistical results of the age of your thing in the mail. So I think, and then we see a slight shift, humans sort of making their way onto the stage finally after we can work out what dating is. So I think, that's clearly a sort of, we see a turn in archaeological analysis from sort of pottery work to sort of population level behavior and settlement things, and we see dating as a really big deal. So we might say, I think this is a good example that's changed the way we do things quite profoundly, radiometric dating. So how does this fit into, what are some ways that we might explore other things that could be a candidate for a sort of image logic shift, like Galison talks about for physics? Is dating the only one that we have, or can we see some other things that might be, that represent this kind of tool-driven revolution that we see elsewhere? So I'm going to step away a bit from this sort of aggregate level analysis now to a couple of case studies that I just want to motivate my sort of argument with here. So this is a map from PNAS in 2007, a group of archaeologists working in Cambodia, Angkor Wat, and they used LiDAR in a very impactful way, and it made all the newspapers, and it was very exciting. And LiDAR is kind of a sort of landscape 3D laser scanning method, I guess, and their big finding was that the residential area of Angkor Wat was a lot bigger than what we had thought it was before. There were many more people houses of sort of ordinary people on the landscape. So there was great excitement about this work. I mean, obviously, LiDAR is an exciting technology, and many of the images that they can create are very visually appealing. And the notion that we had gotten Angkor kind of wrong at the size is sort of startling as well. But I want to ask the question, has it really transformed the way we think generally about empires and settlements? Like, has it really been transformative for archaeologists who are not working at Angkor in particular, but who work with sort of empires and settlements and large kind of or human organizations like that? And actually, I'm going to say no. I think it hasn't been. I think, sure, it's given us a sense that the area that's occupied is bigger, but the really transformative understandings of empires and sort of relationships between elite and non-elite has only really come from the excavations at Angkor and I think elsewhere as well. So this is a recent publication, excavations at Angkor. They did this LiDAR. They dug in a couple of places that looked interesting anyway, but they sort of felt that the LiDAR compelled them to dig there. And they found that what was thought to be these kind of elite residential enclaves actually had a lot of normal people living in there, a lot of sort of working class people, if you like. So that is a transformative finding about Angkor, that it wasn't a very highly segregated landscape, but the elites and sort of farming people kind of lived fairly close to one another. So I sort of feel like the LiDAR hasn't really moved the needle in terms of the way we think about empires and relationships between elites and commoners and so on. So another example I want to share with you to sort of provoke the question of where are these tools in revolutionary archaeology is in the area of stone artifact analysis. And this is something that I do as part of my archaeology, and I'll use another example, come back to this a bit later on. So the smaller scale, right? So I think we do have a good image logic kind of analog or potential analog amongst stone artifact analysis. So this is a paper from Science from the 1960s by Francois Borde, who kind of was a very prominent researcher who worked on the Mysterion of France. And his illustrations are a sort of classic image. In the sort of history of science, they're just a beautiful image, like very clear to see, very, very attractive, very aesthetically pleasing, very informative. I mean, we can clearly see what these artifacts are like and what their attributes are. And this has become kind of like the canonical sort of statement of what a Mysterian assembly should look like. Where is the retouch and what are the shapes of the artifacts and the arrangement of the dorsal plate scars and so on. This image is kind of the data set for understanding and learning about what the Mysterian is. So beautiful and informative image that people use. Is my assemblage Mysterian or not? And they will refer to these kind of images and say, well, yes, it looks a bit like that artifact. I think we do have the Mysterian here. And this is an actual way that archaeologists work. And I work with a couple of archaeologists in China, and they're doing exactly that with their own images. They look up pictures of the Ordzian typology, and they say, yes, I think we've got the Mysterian here. We're going to publish in Nature, something like that. So this is a very classic image kind of approach. And it's persistent. So this is from 2012. Eric Boida is very much in the center of this kind of French style of doing stone artifact analysis. And you can see his publications really centered around these images. And this is a very sort of qualitative image. There's a couple of arrows, and even the caption says a technical biography. So it's very sort of anthropomorphized, I guess, like the artifact has a life, and we should reconstruct its life history through these mapping events. So, and this one is from northern China, and we're sort of agonized about really how Mysterian is this, because this is the paper it says there's the Valhalla in China, and we're arguing about that in another site. So there's sort of biographies and gestures and this kind of very humanistic approach to stone artifacts, which put it really firmly, I think, into this kind of image, kind of typology of ways of doing science. So we can contrast this in stone artifacts with what I think is a good example of the logic approach, right? Where you're using something, this is a digitizer up here, and you point the tip of that thing on a point of the artifact and press a button, and 3D coordinates are captured directly into your computer, ready for analysis. So this I think is a good analog for the logic sort of type that Galison talks about. The data is captured directly in a digital form. There's no looking or images or things like that. And we're looking, and the data is in the form of length and width and thickness. So it's not really this kind of just take a look and have an impression about what it is. It's very formal and structured about where's the measurement to be taken and so on. And And then the output, or what you are permitted to do with it, is this kind of linear discriminant analysis. This is a Paleolithic assemblage from India. And the question is, how does it fit in relation to like Middle Stone Age assemblage from Africa? And we can see using the sort of statistical reduction of these numerous measurements of the artifacts that it fits in quite well. This is the assemblage over here. It's in this kind of Harrison Fort, South African Middle Stone Age. So it seems to me like it's very sort of metrified, metric. Lots of measurements that go directly captured digitally. There's no sort of looking or visual element, not so much in this area here. So I think this is a good example of the contrast of this sort of image logical stuff. So that's my sort of anecdotal account of what we could see potentially. The question is that if we go back up to an aggregate scale, does this actually happen at all? Or is there just one or two people around the place doing this and it doesn't really catch on? So back to a bit more bibliometry. So I sort of roll these two ideas, the LiDAR, sort of landscape survey, and this small particularistic artifact measurement into a general sort of topic of 3D, right? Because I think that's the sort of high-level term that kind of unifies those two methods as potential, logic type of approaches. So these are, I went to the Scopus, which is a database of especially journal publications. I think it's owned by Elsevier. And I just looked for articles that talk about 3D and archaeology in their title, keyword, or abstract. And so here's this is the count of those articles per year. And it seems that they start at 2006. And there's quite a good rise. It looked like this was a promising part of archaeology to be in. And then it seems to have kind of flatlined, around 2013. It's not really a growth industry anymore. The people that are doing it are staying with it, and there aren't really a lot more new people coming along. So, but let's see, this is a bit difficult to interpret by itself. So if we put in context with, say, all archaeology articles published around this time, let's see how does it fit in terms of the trajectory of growth and so on. So this is everything in Scopus from 1990. I just cut it off there for convenience. And so you can see, I just will point out the difference in magnitude. So here we've got like a steady 15 or so articles per year that have 3D in their title, abstract, or keywords. And then of all archaeology articles, we're looking at about 1,500. So they make up like 0.1%, and it's holding pretty steady. So it's not much really of output, and it doesn't seem to be taking off. But there's a couple of options that might complicate the picture, right? It could be that these are really seminal papers, groundbreaking things, and now the 3D stuff is so normal. People don't say 3D in their title, abstract, or keywords anymore because it's just normalized. We don't sort of need to advertise the fact that we're doing it anymore. So maybe these were just the beacons that shone the way, and now everyone is doing it, and it doesn't appear in the we can't detect it using this kind of method. So I thought, well, we can test that idea if we're missing the point by looking at the citation data for these pages that talk about 3D and see whether or not 3D has had this kind of is a tool that's driving a revolution, or it's just a kind of flash in the pan, I guess. So let's look at the citation data. So these are, this is by year and the number of times each paper is cited. So this paper here has had nearly 1,000 citations. And we're looking at about 17,000 papers in total. These yellow squares are the ones that talk about 3D. So we see, and the roof is 1 down here. So we can see that it sort of fit within the normal range of papers, of archaeology paper citation rates. There are a couple of really standout ones, maybe by some of you right here, I think. But overall, what we're not seeing is they're not consistently peaking in the citation rates. So these are not kind of the groundbreaking papers that everyone is citing and everything because they're all doing 3D stuff. So, and here I've got, because so many papers are actually not cited at all, I thought I would look at the median citation rates of articles that are cited at least once, because that may give us a clearer picture. And so we've got 3D in yellow here, and there was this great period of interest around 2007, 8, 9, lots of citations for a couple of papers. And then the rate drops down to kind of the background rate here, still a little high, and then maybe it's kind of really trailing off 2 years ago. So we're not seeing, I think, an outstanding amount of interest in 3D methods looking at those citation data. And in this one here, we're looking at the growth rate of the growth rate of the number of articles, not the citation rate in this case. So I'm looking to see, like, is there the number of articles that are appearing about 3D archaeology, are there more and more of those appearing than of regular archaeology articles? So is this a taking off thing? Are we launching off into a brave new world of 3D archaeology or not? And so we see again, like the citation data, a lot of interest in 2008, 9, and then really the growth rate has become negative again. So there's actually fewer 3D articles published than the year before around this time here. So what can we make of these metrics? I mean, these could all be wrong. The Scopus database is not complete, and this is a lot of things like book chapters and journals that are not captured by the Elsevier database. But can we try to answer the question of is the 3D model, 3D technologies, a sort of flash in the pan, or are they a tool that is going to drive us the revolution? What I think a sort of parsimonious story that we can tell is that it did certainly have that appearance for some time. There are a bunch of papers, highly cited, that looked quite impactful, around 2008 and 9. And then the rate seems to have kind of normalized and fallen into what looks to be the sort of background rate. And then even then the production of papers talking about 3D seems to have sort of been decreasing, actually. So it looks like it hasn't really stuck. It doesn't seem to be taking over from like conventional ways of reading artifacts or reading landscapes. So I'm going to switch back now from this kind of aggregate level of analysis to a bit more particularism, and to see kind of what some of these 3D articles are about, these high impact ones, might give us some insights into perhaps why 3D technologies haven't really hit mainstream and replaced all the other ways that we sort of manage take information out of artifacts in the landscape. So here I've got some word cloud of all the articles that mention 3D, that I filtered them. So these are just the ones that are cited 10 or more times, so we can call them kind of high impact papers. And then I'm looking at the text of the abstracts of these papers. So the number afterwards is the frequency of that term in this sort of corpus of high impact 3D archaeology articles, articles about 3D archaeology. And I think what's really revealing, so there's a lot of technical terminology around here. So modeling, processing, measurements, record, and so on, create, airborne, sort of technical vocabulary. But what I think might be particularly revealing, well, the two very revealing things, what's there and what's not there. The revealing thing that is what is there, I think, are, let's see, museums and monuments and heritage and culture and documentation. They sort of sound to me like these methods are being introduced in the context of CRM, right? And they're being sort of sold to the reader as something that can improve or be beneficial to CRM. And they're not being either pitched as or having any demonstrated kind of value to people who are doing basic research in archaeology, which I think is what most of these papers in this Scopus database are about. Now, what's missing from this word cloud are really words about human behavior, and things like adaptation and agency, and things like, I think the core business of archaeology is understanding past human behavior. And I don't see a lot of terminology relating to that task in the text of these articles. So what I see is the way that 3D technology is being discussed, it doesn't intersect very well, actually, with the sort of core mission that most archaeologists identify with. So it might be what's happening is these technologies are appearing and being published, and perhaps either finding a niche or creating a niche for themselves in CRM, which typically doesn't return a lot back to the scholarly literature, but they produce sort of products for clients in other ways, and we're not seeing it in these kind of bibliometrics. So, moment of reflection. How can we interpret these results, these kind of anecdotes and the bibliometrics, using this conceptual framework of Galison's tool-driven revolution? So, I noted that the idea of dating really stood out in the full analysis of the full text of American antiquity articles. And so, is this a tool that has driven a revolution according to Galison's approach? And actually, I think we can argue that it is. I think that instead of comparative and stratigraphic methods for dating, the introduction of radiometric dating really did have that tool image shift, because stratigraphic and comparative methods very visual, We have to look at the artifacts and see are they the same. We have to look at the stratigraphy and trace it across. But radiocarbon dating and radiometric dating, we send things off to the sort of industrial facility and we get back a series of numbers, right? We're completely removed from the process as archaeologists. I think anyone who's ever got a radiocarbon date, that's a pretty typical experience, and that's also what Galison documents to physicists. You know, they have these engineers building these vast machines that the physicists don't really have much to do with it anymore. They just get the numbers out and kind of then work on it back in their office. So I think the introduction of radiometric dating is really the best candidate, the most obvious candidate for this sort of tool-driven revolution. What about 3D technologies? You know, like scanning artifacts or digitizing landscape and so on. Do they count? Is that another domain of archaeology where we see a tool-driven revolution? Is there an image logic shift somewhere in there? And I did suggest that there could be in the way that artifacts are treated in the sort of French style versus the digitization style. But actually I don't think so. I don't think that it qualifies as that kind of transition. And I think you know, we're not seeing a diffusion and a wide adaptation of these technologies in the way that we would if they were revolutionary, in the way that we see radiocarbon dating being so ubiquitous. Instead, I think what is happening is they're finding a niche in CRM, in some cases a problematic niche, as we saw from that arch that Eric showed earlier. But most archaeologists doing basic research are not going to 3D technologies to replace their sort of core methods of reading the landscape and reading artifacts. Not yet, anyway. So there's a relevant perspective, coincidentally relevant, that I found recently in Leora Grossman's paper on computational archaeology, published in the Annual Review of Anthropology, and her paper is very optimistic. But independent of that, she makes this comment, sort of concluding comment about advanced imaging technologies in archaeology, and she says, she sort of presents it as quite transformative, but I think this quote kind of belies that a little bit. So she says, you know, what we see is a shift from of the older style of working with you know, photographing and drawing artifacts and so on, to 3D scanning of landscape artifacts and stuff. She's talking about the shift from photographs to the moving pictures. She sees it as that sort of dramatic scale change in the production of data and so on. But I think coincidentally, you know, if we sort of look at this through the lens of Peter Galison's work, these are all just images, right? There's no logic in here in his sort of image logic system. So what we see with you know, the 3D technologies, I think, is just another kind of working on images. We haven't seen the stepwise shift from image to logical technologies that sort of radiocarbon dating might be, for example. So if I return to the question that kind of motivated my use of Peter Galison's concept here, does our celebration of speed and efficiency and so on make technology a superficial distraction for archaeologists rather than substantial? I would lean to answer yes. And I would say that most of the time our engagement is superficial. When we compare our situation to physics and chemistry and biology, where there's some nice cases of technology being transformative and diffusing widely and really becoming a sort of ubiquitous thing in people's labs. In archaeology, I don't think we've seen that so much. I mean, we've seen with 3D technology, that's kind of a flash in the pan. Maybe everyone does have a 3D scanner tucked away in their lab, but they're not using it as part of their day-to-day sort of core basic research. So we might ask, why not? Like, why haven't we seen lots of tool-driven revolutions like our colleagues in chemistry and physics and so on? And what do we have to do to make a sort of shiny toy do something useful for us? What can we do to create the conditions? What can we do to create the conditions where a tool-driven revolution might occur in archaeology? So I'm going to try to answer those questions using this concept of hard cores, which comes from the work of the philosopher Imre Lakatos. So he presented this idea of a scientific research program, and really was in opposition to Karl Popper and his model of science and non-science. And I think most archaeologists are quite familiar with Karl Popper because he was very much beloved by Louis Binford, who's kind of a transformative character, if not slightly like aggravating in the history of archaeology. So, you know, as many of you know, Binford had this sort of early obsession with Hempel and this sort of law-like hypothetical deduction, sort of strict formalisms. And then I guess as he aged a bit, he shifted to Popper as a slightly more kind of user-friendly philosopher of science. So Lakatos has and Lakatos is a contemporary of Popper and sort of proposed this sort of alternative way of thinking about what is science and non-science and falsification and so on. But in the archaeological literature, it's sort of surprisingly not had a lot of attention. So I'm pleased to be able to kind of raise his profile amongst the archaeologists here. And so the crows, of course, are in for Popper. When people learn about Popper, it's or ravens. In fact, all ravens are black. And all it takes is one white raven to come along and sort of disprove that whole hypothesis. And that's sort of entry level to Popper. But with Lakatos, we propose an update on this kind of falsificationism that Popper introduced. And his version is called sophisticated methodological falsificationism. And so the sophisticated bit can be contrasted with naive. And so naive is like you get a hypothesis, you falsify it, and then you toss it away. And that's the naive Popperian approach. And Lakatos says sophisticated falsification means you can replace a hypothesis at any time. You don't have to wait for it to be falsified. If a whole bunch of other hypotheses look like they're on the brink, you can just ditch a couple of others that might depend on it and sort of clear your slate ready for another set. He sort of believed in families of hypotheses and theories and so on. So this means, sophisticated means a proliferation of theories and hypotheses, a clustering of sequences at once. And in the methodological part of sophisticated methodological falsificationism, it means having conventions, having rules about how we undertake the falsification tests when we evaluate our theories. So this notion of being methodological, having conventions, I think is really crucial. And I think we've heard the idea kind of bubble up a couple of times today already when we talk about standards and conventions and ontologies. It's directly related to this idea of conventionalism in Lakatos. So this idea of conventionalism, it leads to the observation that, as a community of researchers, we make a sort of collective decision that some theories are not allowed to be tested. We kind of hold them sacred, right? After extensive sort of trial and error and a long history of working with them, we just sort of park them aside and say, okay, we're done. Those are true. There we regard them as like an extension of our senses. We're just like, yep, we just know that to be the case. And we let them go unchallenged and we use them to challenge other things. So this is not the same as having like a bedrock of concrete truth. It's more like piles in a swamp, the sort of things that we more or less agree to be okay for now until something really challenging comes along. So this means that, and I find this to be quite honest, it's very appealing, it's a very honest way of thinking. We sort of agree that these are true based on extensive trial and error for now, but we allow ourselves to be, to have the rug pulled from beneath us if some really startling evidence comes along. So I'm going to skip over a little bit of some of the really interesting bits of Lakatos and kind of encourage you to read it yourselves to get onto the bit that helps us understand where we can look for opportunities for transformative change in archaeology. So he says that Lakatos, other theories are falsified by other theories. Theories are falsified by other theories in light of evidence that affects those, rather than the evidence directly falsifying the theory. Right? So this leads us on to the most interesting part, which is the methodological rules and conventionalism. And it tells us these are the rules, he says, which he claims to be observing in scientific practice, not ones that he's making up for us to follow, but ones that he says are what people actually do. We have two sets of rules. Rules that tell us what research not to do, right, the negative heuristic, and rules that tell us what we ought to do, things that are sort of safe to pursue. So the negative heuristic, the rules that tell us don't research those things, this gives us the hardcore of our program, which I think is a really useful idea for understanding how archaeology and sort of research communities in general work. So hardcore are these sets of assumptions that we basically consider more or less proven because we've already spent a lot, or our predecessors spent a lot of time investigating them, and we're basically, that extensive trial and error, and we can just kind of park them aside and say, okay, no further testing needed on those. These are kind of the assumptions we hold to be true together. So we consider them kind of irrefutable by this, methodological conventionalism. We just agree that's the case. So that's the negative heuristic that tells us what not to do. And the positive heuristic is this kind of protective belt around this hard core of theories. And so we sort of come up with clever ideas to test things out in this outer belt of ideas and theories, which kind of protect these hardcore ideas from being discarded. So we can think of it, and a picture of this way of thinking about communities of science as in a sort of planetary model, right? So here's Saturn and the rings, and Saturn is this kind of hard core of things we basically hold to be more or less true most of the time. And the rings are these kind of auxiliary hypotheses and things that are up for debate and competition and stuff that we've researched actively and challenged with evidence. So that's kind of a nice way to think about that. And I can give you a sort of famous historical example to help you translate this sort of hardcore protective belt thing over to archaeology with this story about Mercury. So this is a famous kind of episode in the history of astronomy. And there's Mercury there, and Kepler and Newton had devised with incredible manual labor how the planets ought to orbit around the sun. They had considered it must be an ellipse, and the sun must be one of the foci of the ellipse. And they'd also predicted this thing called a precession, which means the whole sort of elliptical orbit sort of moves. Here's a picture of it here. Moves over time. So this is there's, for example, Mercury moving around. Here's the ellipse. The sun is at the foci. They sort of predicted this with incredible precision by hand, just through their observations of the sky and the calculus that they had developed themselves. And they predicted it would sort of move around this whole elliptic kind of circle around. There would be a precession effect. So throughout the 19th century, people were observing this with increasing precision, and they found about a 7% error in the predictions that came from Newton and Kepler and their actual observations. It was well above like their normal level of observational error. So this was a real problem, and it meant potentially throwing out Newton altogether, which of course has diabolical consequences for our understanding of how the world works. So Newton and Kepler are the hardcore, right? They really didn't want to do anything that would involve dismissing the theories of those guys because they kind of worked so well for everything. Every other planet was predicted really well by their theories, but Mercury was not good at all. So there was sort of a couple of decades of incredibly inventive theorizing about what could be causing this 7% error, right? So they thought maybe there was another planet out there that hadn't been found yet that was kind of pulling Mercury off in another direction. They even gave it a name, Vulcan, ready for its discovery. And this seemed plausible because that was what led to the discovery of Neptune. It was an irregularity in the orbit of Uranus. And others thought maybe there was an asteroid field or dust or sort of invisible things. And they sort of increasingly complicated theories that they came up with to protect the theories of Kepler and Newton as the hard core, right? And in the end, it turned out that Einstein came along and said, oh no, this is just the warping of space-time because Mercury is right near the sun, and the sun is this heavy thing, and the sort of fabric of space is kind of warped like that, and Mercury just kind of wobbles around this warping of the fabric of space, and that kind of explained the 7% error apparently. So you see there's this hardcore of ideas, hardcore theories, and then there's this sort of protective belt of other ideas that are proposed and tested and so on, because no one really wants to throw out those hardcore ideas because they work so well, and they help to sort of protect things that generally work well for this kind of dogmatic falsificationism. It says one bad thing, we've got to throw the whole lot out. That's kind of a Popperian system. So I think that's why the view that Lakatos has of how science works is quite appealing, because I think it reflects how we actual behavior. So what does all this stuff about cores and belts got to do with archaeology and digital technology and sort of changes in the discipline and so on? So I want to propose that disciplines in general, scientific disciplines in general, that have hard cores tend to be more susceptible to technologies that can be transformed, to tool-driven revolutions. And areas of like scientific research programs that have like diffuse cores or many separate ones, it doesn't stick. A new apparatus or instrument is not quite as valuable and isn't going to diffuse as efficiently and become as transformative. So I think a discipline that has hard cores, or where the hard cores are in discipline, that's where we can expect to see the best potential. And I think this is why the idea of conventionalism is so significant for archaeology, where we can look in archaeology and find conventions. Why they share, those are the places where we can expect to see a tool-driven revolution or some sort of digital technology really make a big difference. So I'm going to go back to some bibliometrics to try to look into archaeology and see where are the parts of archaeology where the hard cores are, where we can expect to invest energy in introducing or training in digital technologies and get a reward, get some return. Oh, I should mention that Lakatos, he was in the business of science versus non-science, and he dismissed Freudian psychoanalysis, Marxism, and Darwinism as non-scientific, actually. And I would of course been most curious to know what he thought about archaeology, and I sort of have a bad feeling that he might consider it a bit unscientific, but I hope you just bear with me that I will assume that for some parts of archaeology we are scientific, and all of this sort of analogies to what's happening in physics kind of have some value. That is an assumption that I would totally understand in my query. So let's look and see where these areas are. So I had a bit of a look. This is a result of unfortunately difficult to reproduce scraping of the web of science, and there might be 100,000 articles in here. And I looked at every decade to see what are the most highly cited articles in archaeology. And my sort of thinking was that the areas where there are hardcores, they're going to have highly cited articles that seem to be consistent decade by decade. Whatever this hardcore is going to be one that we're going to see papers about repeatedly over time and highly cited, because other people in that community will latch on to this new idea or this new approach and then publish prolifically on it and cite it a lot, and we'll see we can imagine this is the sort of trace of auxiliary hypothesis kind of ordering around a hard core. So this is a little difficult to read, but I've got some close-ups coming up. So here's this kind of overview of about 100,000 articles from Web of Science, the top cited articles in archaeology per decade. So here's 1970 to 80. And just a quick scan of the titles. You can see calcium carbonate, trace element analysis, magnetometry, X-ray diffraction, spinal stuff. Let's have a look. 1980 to 90. There's a paper about agency, which is, I'm surprised by that. Sea level changes, skeletal parts, there's something about lithics, alluviation, and then there's Binford's famous paper there. What have we got? Bones, raw materials, measurements of bones again. Started with various high-air bone, burning, isotopes, dating. This dating paper, optical, is by far the most cited of all of the papers in this database. I think it's all the luminescence people churning out little 2-page papers, hundreds of them a year and citing. So we've got minerals, organic matter, nitrogen isotopes, bones, environmental, and so on, strontium isotopes. And this, of course, is incomplete because we're not quite finished with this decade yet, but XRF, compositional analysis, with the bones. So XRF. So I think part of this is kind of artifact of the Web of Science database. It obviously doesn't collect every single journal. It tends to be it's biased to the journals that have a very high rate of production, like Journal of Archaeological Science and Archaeometry. What seems like thousands of articles per year in those. So what does this tell us about where we can find our hardcore? What can we get out of sort of our kind of glance over the titles of those? And I think what we see is that zooarchaeology and geoarchaeology are kind of the places where the articles are being consistently highly cited. So someone is kind of having a breakthrough in the development of some geoarchaeological method or some insights into bone preservation or something like that, and that's making a lot of impact amongst people who are doing related things. So there's this kind of they're having a hardcore of concepts and theories, and then people are contributing these auxiliary hypotheses, and I think those auxiliary hypotheses, we see them, they emerge as a paper, and then by the time they're a highly cited paper, maybe they're making their way into the hardcore. I think that's the sort of process that I think we see a trace of in some of this bibliometric data. So I want to comment now on a couple of, sort of zoom in again away from the sort of aggregate level on a couple of individual papers to try and get a bit more of a sense of why should these parts of archaeology be the ones that are getting all the citations decade after decade. What grounds do they have to be the hard cores where we should expect digital technology to be transformative? So here's one that I found really impressive, and I think is a good example of why zooarchaeology in particular has this kind of potential. So this is a paper, the Turkish spread of the Neolithic in Turkey, and at least one of the authors is with us, maybe another. And it's impressive because it's a huge aggregation of data sets from a whole bunch of different projects, and somehow they managed to get some sort of meaningful information out of a whole bunch of different ways, different sort of projects with different individual objectives, the data was sufficiently comparable to be useful in this kind of massive aggregate way. So I think this is really an amazing kind of demonstration of why zooarchaeology has this special position. And we heard a little bit earlier about standards. And I think it's the zooarchaeologists are very fortunate that they've got all these standards because animals animals of the same species have much the same kind of bones, and all the bones have parts of the bones have much the same kind of names, and all these things are just worked out and standard. And so they borrow all of these things that are already just done in biology. And because a bone is much the same from one, a sheep bone is much the same from one side to another, it's fairly easy to come up with an ontology that is easily interchangeable between different projects, even if you're not motivated by the same kind of research questions. So that's a great example. And there's another nice quote on a paper that's really specifically about how useful or not is data, other people's data, that I think articulates why zoology is so privileged. And it's to do with this they say common conventions, right? It's unusual because we have many common recorded conventions in zooarchaeology, right? So, and that's what makes it such an area that is ripe for being we recognize as a hardcore archaeology. And we can connect this back to Lakatosh's idea of conventionalism. Like, conventionalism is strong amongst zooarchaeologists. So it's relatively easy for them to exchange data sets and get value or make their data sets useful, even if it was collected by someone else who was trained in a different tradition and trying to answer different kind of questions. The data is interchangeable with much less effort than other fields. So here's an example from what I really like from geoarchaeology. So this is a metallurgical study. This is a little bit different because really one author, I think, did most of the metallurgical analysis, but the other authors were involved in, recovering the thing and sort of being on board with the kind of questions that this guy could answer with that analysis. So they volunteered their samples or sought him out and said, look, I've got some metal from the relevant period. Could you tell me how it sort of connects to regional trade networks and so on? So, and maybe there's a sort of, I'm not sure what the effect of having a large number of authors is. I think there may be large numbers of authorships in archaeology may also be a sign that a hardcore is around, because simply getting that many people together on the same kind of paper is incredibly challenging, and I'm sure many of you know have tried to organize it. Anything beyond one or two authors is really challenging to get up literally on the same page as well as kind of metaphorically. So what about the areas of archaeology that lack a hard core, where there is no core? How can we identify those? And what is their problem? So I'm sort of sad to report that in my own sort of specialization of stone artifact analysis, I think this is one area that really lacks a core. And I've got just a gem of evidence to show you this. So this is a paper published from last year, Major Fallacies in Stone Artifacts. What gall? The title like that, it basically says if you're not one of us, like on this authorship list, you're probably doing it wrong. You probably have something wrong. So here we say, potentially informative, but many of the assumptions that we use, so the hard core that many people who study stone artifacts claim to have, do not fit squarely with what we know from ethnographic and archaeological materials. So basically they say that your hard core, the people who are not us, is wrong. It's empirically sort of problematic. And so they go on to sort of point out some of the issues. And I guess for safety's sake, I side myself with these authors. But I feel a bit sad for my colleagues who are kind of not in this group and are on the sort of what they identify as kind of shaky foundation. So you see that stone artifact archaeology has no hard core. We're just kind of flailing about. Some of us believe that we have sort of good foundation of assumptions that where they're well tested through trial and error, we can just put aside. But clearly some archaeologists believe that people who believe they have their own hard core, they're wrong about that. Here's another slightly more detailed example. This is a paper about, I think within the last 5 years, about the chaîne opératoire, which is very sort of European or French style of analyzing stone artifacts. That's very much the image-based style that I mentioned earlier. And you can just see how brutal a criticism is here. So it's one of the most serious of these. It's extremely subjective, right? Nobody wants to tell you to be subjective. Extremely subjective, based on analytic experience, intuition. So there's kind of like a death knell to your method. Another problem is it relies on intentions and desire. And so, I recognize there's a field, there's an area of archaeology where people do research their desire and intentions, but usually in Pleistocene archaeology, the convention is not to entertain that we have any way of knowing about desire and intention. So this is kind of a problematic assumption for most Pleistocene archaeologists. And the third one is severe inconsistency in definition. And there's a sort of long catalogue that goes on about, they originally proposed these 6 types, and now there are 12, and the names don't match, and when the names do match, the definitions don't match, and so on. So it's really an unfortunate situation in stone artifact archaeology. So I'm not sure that we can find a hardcore in that part of archaeology, but I think we've got a reason for a lot more optimism in zooarchaeology and geoarchaeology. So this kind of brings me to my response of the second question: how do we encourage more meaningful intellectual engagement with technology in archaeology? And I think the answer is, how can we expect digital technologies to be a bigger and more transformative part of archaeology? And my response is that we find these hard cores, which I'm proposing to you, are zooarchaeology and geoarchaeology and related things, and then match up a technology that exists, that serves a need that those people have, and that sort of can be part of their research conventions, that can make their life easier in some way. So we have a sort of a related question like, okay, what about all these other areas? How do we stimulate a hardcore or create one amongst my friends who study stone artifacts? How can we cultivate that? And I think the solution can be found in this sense of, we talked about standards already and Lakatosh's idea of conventionalism. Somehow cultivate or establish robust and widely held conventions. And then, about what to measure and how to measure it, especially. And in many areas of archaeology, I think we lack that, beyond sort of small groups of research communities. So that's kind of my sort of reflection on the second question of finding the areas where we can put digital technology to work to really be transformative in this kind of tool-driven way. So I want to now sort of follow up and address the third question. How can we know how to be the most useful? Like, what digital technologies stand the best chance of being transformative and the most useful for the most people in archaeology, right? So many gadgets will benefit some people most of the time, but not everything will benefit everyone all the time. So I'm trying to think, what in other disciplines can we see has been beneficial to most people in that discipline most of the time? It's kind of widely diffused, and it's really independent of the stuff that you work on, or the time period, or the tradition of your training, right? So I'm going to answer this question with this concept of mirror recursion. And this is what was proposed to me in an anonymous peer review comment, and I just wish, maybe it's one of you, I just wish I could give it proper acknowledgement, because it's really compelling way of thinking about ourselves as archaeologists. So this is my sort of shorthand, mirror recursion, for how I think archaeology is uniquely placed to engage with digital technologies, and how where the biggest bang for buck can be found, I think. So the idea of a mirror, obviously, is the notion of looking in the mirror and getting what we see in our reflection. When we see ourselves in the mirror, we obviously see a great archaeologist, but we also see someone who's like participating in the creation of an archaeological record. And I think that might be studied in the future. I think secretly, deep down, we sort of imagine that. At least maybe I'm just making an embarrassing confession, but I'm sure that as archaeologists we navigate the supermarket and we think, what's the optimum way to utilize this sort of patch of resources? Or if you're in town, like, how are power relations being negotiated by this architecture and the organization of public space and so on? So I think we sort of think of ourselves as part of the archaeological record as well as creating or decoding it. But when we actually do look in the mirror, or take a more honest look, I think, what is the sort of truth of our situation, about our sort of self-image, I guess. And I think really what it is a bit disappointing. Like, our role in creating our archaeological record is quite minor. We don't really spend a lot of time burying time capsules around the place or erecting giant monuments that are going to last for thousands of years. So what about, how can we redeem our self-image as archaeologists? And I think part of the good news comes in this notion of recursion. And so here is the rather amusing Google search results for recursion. And it had me, I was like, wait a minute. So, but down here, it's quite a useful definition down here, when the thing is defined in terms of its own type. So, it's like archaeologists doing archaeology to themselves, is how we can imagine this sort of recursiveness as an archaeologist. So, rather than waiting for ourselves to die and millennia to pass and some future archaeologists to come along, what would be the result if we did an archaeology of our own archaeological work kind of like 5 minutes ago or last year or something like that, our own behaviors. And so a little bit of contemplation of this sort of kind of silly thought experiment reveals a bit of a paradox, I think. So we spend really a great deal of effort and time and money and so on trying to understand past human behaviors, through material remains and traces and so on. But if we look for the material remains and traces of our own behaviors, as we do the work of being an archaeologist, what do we find? So, we might find a couple of artifacts in a museum collection somewhere, and we might find, what are we going to find that really is revealing about the process of creating the knowledge and producing the monograph or the article that is kind of our standard output. And I think if we're lucky, the traces might be, a handful of garden tools and a laptop computer, and that's kind of good. So I think this is because the culture of our discipline, which is not unique to archaeology, really encourages in the manufacturing of archaeological knowledge secrecy and privacy, and we sort of ephemerality of the way that we do things. We keep the files on our computer or on our lab server. All the analysis done through a spreadsheet or SPSS or something like that, and we keep that to ourselves. Again, we don't share it with anyone. And so, there's a lot of secrecy and ephemeral behaviors that leave no trace. The sort of all the clicking around of a mouse in an Excel spreadsheet. Once you shut your computer off for the day, what is left of that? There's maybe a couple of cells in the spreadsheet that have some numbers in it that didn't have the numbers before. But if someone were to pop your computer open and try to sort of look for the traces of that behavior, they'll be disappointed and maybe frustrated. Like as an archaeologist, your obligation to humanity is to leave a better trace of your own behaviors because you're so sensitive to those issues. So, our training, which is not unique to archaeological training, kind of conditions us to leave no trace of our analytical work, to just be sort of invisible, to let that part of our existence be go missing. So that's the paradox. For a group of us that claim to be very interested in past human behaviors and the traces and remains of that, the way that we go about it ourselves makes it almost impossible for anyone to understand our behaviors as archaeologists as we do the work of archaeology. So how can this idea of mirror and recursiveness answer our question of, how should our embracement of digital technologies transform archaeological practice? Where is the level that we can sort of insert something and hope for transformative stuff? So I discussed, what I'm going to present as my answer to this in a short essay in an online sort of news service called The Conversation, in a very general way, not about archaeologists, but in the general points that I'm going to tell you about. And there was some interest in it, and it was picked up in French and German and Japanese, and someone is working on a Chinese translation now. So it seems to have hit a nerve, the idea that a lot of science happens on a computer, and yet what happens on a computer is terribly unscientific because there's no record of it. It's often not reproducible, it's not transparent, it's not available for inspection. Right? The notion of science is from the 17th century is that someone could come and have a look and see you doing it and see it for themselves. Right? So when as computers sort of become increasingly part of scientific activity, that idea has kind of become very difficult to maintain. So that's where I think we've got a really rich sort of opportunity in archaeology to be transformative. So I spent some time preparing that article and subsequently looking across other disciplines to see what sort of technology has entered into other disciplines had really high impact on the way people operate and been transformative that is not specific to that field, that is not a particle accelerator or a next-gen sequencer or something like that, but something very generic. So this diagram here is sort of data volume, and it's just a sort of nice way of kind of organizing the communities of science. And most of us are not up here. This is like Large Hadron Collider and the Gravity Wave Project, and thousands of people and billions of dollars and that kind of thing. And they have bespoke solutions to their problems of transparency and reproducibility and so on. And the technologies they've introduced to those have really been transformative. We are more like out here somewhere, as this chap. This is from Tony Hay, who writes about the fourth dimension as data science is a new way of science. And this, I think many archaeologists can relate to this kind of environment of doing research. Maybe some of the larger projects that we heard about earlier today are really more in here, where they've got bigger groups and data sets and large collaborations. These sort of like big classical archaeology projects out there. But I think the common garden archaeologists like me and many of my students and colleagues way down here. And as evidence for that, I've got in this Scopus data set, I had a quick look, and in terms of the numbers of authors on a single paper, right? And these kind of large hadron collider where there's hundreds of authors. In archaeology, the median is one. Most archaeology papers are authored by a single person in this. There's about 17,000 papers in here, and 81% of 3 or fewer. So the average archaeologist is a single researcher publishing more or less by himself, right? So they're way out here. So I've tried to look and see what kind of things are people doing up here that seems to be transforming their practice and really being high level diffusion of technology that we can adopt down here. And this is what I've come up with. This is a visual version, I guess, of this short paper I had in the conversation. So I've seen people in the physics, and biology, and genomics communities talking now about the traditional sense of the journal article, as we know, as it is for the most part, advertising, the tip of the iceberg. It's just a sort of taste of what happened. The whole research process and results are really not there. It's just a couple of pictures. And they're saying now that the text and final results in the traditional journal article is no longer adequate for communicating science and being persuasive and being useful. If you have a new method or a new result, how can other people use your method easily or investigate the veracity of your result? It's just the tip of the iceberg, just the advertising. So I see in other fields there's a demand now for the text, which is already here, but to be combined with some availability of data and code. It's nearly always code. Very few people who are sort of agitating about openness and reproducibility and sort of technological solutions are using point and clicking kind of software. And then version control, which we haven't heard a lot about today, and isn't really a big part of archaeology, but it's kind of a track changes for all of these things together. So many of you are familiar, I'm sure, with track changes in Microsoft Word, but what if you have a data set and you change a few values in the data set? How can you kind of control that change and similarly with code? So this system allows you to kind of do a record of all of that and roll backwards to other things, other periods, other times when the code is in condition. So the norms that seem to be emerging from my observations of people in the sort of the fatter end of the tail in science is this idea of what science really is now. There's some product that includes a narrative text, the code that sort of creates the result, creates the visualizations, summary statistics, and some availability of data. And then the sort of key detail is that these things are linked, and we've heard a lot about persistent URLs and DOIs as an example of that, and licensed in a way that they can be reused. And we saw some examples of CC0 already to show the public availability and reuse of the data. So this is what I'm seeing as kind of norms that are emerging in other areas, and what I think are norms that can have great potential in archaeology to be transformative. Because just imagine if you could see if someone had developed a clever method that you really wanted to use, and then they had a code repository or package that you could then just take and put your data into, and you didn't have to reverse engineer their methods paper to kind of rebuild their method from scratch. Think how much time and frustration that would save. So I think, so to make the connection back to zooarchaeology and geoarchaeology, their data sets are structured in a way that's quite useful for other people in those areas. And when more of them shift to using code, then there will be much less friction in being able to aggregate data sets in the way we saw with that paper about Turkish zooarchaeology. And this will become something that can be done as a matter of course, rather than as a highly sort of organized and strategic demonstration of the potential, which that other people said today. So here's what it looks like. Here's what people who are doing this sort of combination of text and code and data. Here's an example of one way that it's going. This is where you write over here. This is a writing format called Markdown, which is it's related, I suppose, to HTML, but much simpler to use. It has all the usual scholarly apparatus of managing citations and cross-referencing and captions and so on. And so this is just a plain text. Those two hashes will create this as a as a heading. The output is in HTML format, but Markdown can be generated into PDF or Microsoft Word as well, so it's quite flexible. This is the plain text. You just type your text in here and type in your code. And so I just will point out, this is R code. You probably recognize it. This is inline code here. So these are just normal words, and then there's a little bit of code right in the middle, and then when we generate or execute this document, that bit of code is run, and in the rendered version, we see the result of that bit of code. Right? So this is, I find this to be miraculous, because copy and pasting now is no longer something we need to do. You no longer need to worry about you receive a slightly updated file from a collaborator and where are all the points in the manuscript that you need to change to reflect this minor update. Because when it's scripted into the manuscript itself, you just update the code, the data file, and regenerate the document, and those places where you're worried about missing are automatically taken care of. So we have inline code, and we have an example of a code chunk. And we can just type the code in like this, and this chunk here just produces this plot over here. In the rendered version, the plot simply appears and you don't see the code. So we can circulate this document as the source file of text and code in one file, and the data files easily through a repository or even by email if the files are small enough, and then someone else can easily run the code. They can insert their own data instead of the data that I've used, for example, or they can explore the code by, if this was a sort of complicated model, they could explore some of the parameters of the model and see, like, have I missed some critical assumption that test that maybe ruins my whole hypothesis. So it allows them to test the veracity of my conclusions by themselves, because they can adjust the codes to see if their assumptions are true or not. So this is what we're seeing in many other disciplines, and they're calling it reproducible research, because the code and the text are together in a single document or closely related, and they're usually made available in some kind of compendium repository. This is often called literate programming, where the text or literature is combined with the programming, so it's all sort of contained in one thing. And so I now write my papers like this, and I teach my classes and make my students do their assignments like that, and my graduate students writing their PhD theses that look like this. Here's an example that shows, this is really a diagram of a project that I demonstrated this approach in. This is more written for a sort of software engineering audience, because it really reveals a lot of the tooling. But what's important really is this is kind of the R environment, and the things, the sort of software engineering equipment that has been developed for people that use R, that makes it so easy. It takes away a lot of the struggle and effort and frustration of working in this very sort of transparent and open way that makes it very easy for me then to share my stuff with other people, and they can then interrogate or extend the work. So I've got various R packages listed here, the ones I'm using for visualization and analysis, and this is the outputting into the Word document, and some sort of quality control of the code, and then it's going out to things that you recognize, Microsoft Word, and then various sort of workflows of collaboration that I'm sure you're all familiar with. So this way of doing things, I call it a research compendium, which is based on some of the infrastructure that just comes with the R programming language, and Python has a very similar sort of ecosystem of things to help you get organized if you're using Python for research. We found this to be a very effective way. So the first one, we did this first in a paper in 2015, this one here, and that was a real struggle, and I had a lot of anxiety that I was spending a lot of effort onto this way of doing things that I might not be able to sustain, and my next paper was going to be a real test. Would I be able to do this again, or would I have to sort of throw that away as like a once-off failed experiment? And in fact now, all of these papers are in the same mold. This kind of research compendium that is based on an R package, where there's code and narrative text and data, all arranged in this very sort of systematic, consistent way. And if you're familiar with R, you'll easily be able to browse the file structure of these compendiums and recognize what is going on and know where to look for the bits and pieces. So I'm pleased to report it's a sustainable approach. And so that's what gives me hope that this technology of reproducibility is one that is a tool that has revolutionary potential, especially if we can get into the hands of people doing zooarchaeology and geoarchaeology, where they already have a lot of problems of interchangeability kind of sorted out. So I now try to include this paragraph into the kind of method sections of my paper, partly virtue signaling to show off to the peer reviewers that I'm trying to do something really great, but partly also to sort of situate the links to the material, because I can't trust the journal's supplementary online material because they often rename the files. They don't understand zip files very well. And usually that's paywall as well, and I don't want my stuff to be paywalled. So I've got to have a place to park the DOIs, and this paragraph makes that clear what the DOI is and what you can find there and the licensing there, because often people know that in a paywall journal, the figures and whatnot are all copyright, and they won't use it because they'll like republish that figure because it's copyright. But if I've got a version of the figure that is CC BY, then that's easy for anyone else or even me to reuse somewhere else. So, but the problem here is, although this virtue signaling is very nice and I feel very sort of virtuous, I guess, I'm probably only reaching maybe 2 readers at best, right? The peer reviewers. I'm assuming that no one is actually reading any of my publications. But, so 2 people per paper. You know, if I might reach a few hundred people in my whole career. I'm not very satisfied with that level of research. So I've been lately thinking of ways to kind of broaden the reach of this way of doing things, which I can see in other disciplines as being quite productive and transformative. And I feel like as archaeologists we stand to benefit in the way that some other people have. So as a part of my plan to sort of broaden my readership, with a bunch of other people, we petitioned the Society for American Archaeology to form the Open Science Interest Group to sort of create a community around these technologies and ways of doing things. And that's been approved by the SAA board just earlier this year. And the coming SAA will be the first where we sort of have our official meeting. And in this is a screenshot of our manifesto, which we've just finished drafting over the last few weeks. And I'm just thrilled at how many co-authors I was able to include on the paper, people who are willing to kind of buy in. So that gives me at least another 45 odd people who are going to read at least this paper. So the Open Science Interest Group, and what our plan to do is primarily operate training, especially through the SAA meetings, and we'll have the first one coming up, to provide opportunities for people to learn in a sort of relevant and supportive environment, like about reproducibility and working transparently, and this approach of literate programming, especially with R-code. There are a lot of archaeologists using R-code, so that does seem like a natural choice for a scripting language to make the research process very transparent. So the Open Science Interest Group, we also have a few strategies to incentivize this kind of openness, which I think is going to be related to transformational introduction of tools. And I encourage you to have a look at the paper to see more about some of our strategies. The paper is, our activities are motivated in a very selfish individual way. So I've looked into the literature in other fields about how do individual researchers benefit from certain technologies and certain practices related to openness and transparency. Like, where's the citation boost? What is the thing that you can do that's going to increase your visibility in the level of citations? And we've discussed some of those in that paper there. So I feel very confident recommending these things as a potential digital technology to be transformative, because they've worked quite well in other fields. And in my own sort of work, they've proven to be sustainable, which is something I was very anxious about. So let me return briefly to the 3 questions that kind of motivated my discussion. So the first one, are we distracted by technology rather than doing substantial work? And I said yes, generally we do adopt a lot of technologies that don't lead to any revolutionary change. Sure, they shave a bit of time off in the field, or they give us more sort of visceral ways of engaging with the archaeological record. But I said maybe with radiometric dating might be the best example that we have of a real mover of the needle in terms of technology and archaeology. And I looked at the specific case of 3D technologies, and I said, well, I don't really think they kind of fit that sort of image logic kind of breakthrough that Galison proposed. We spend a lot of time, we're really interested in making more and better images, but we're not really shifting to the logic apparatus in a lot of what we do. But I think this embracement of technologies related to reproducibility will be that shift. So the second question, how do we encourage more meaningful engagement with digital technologies? And I talked about this idea of a hardcore and auxiliary belts and so on. And I identified zooarchaeology and geoarchaeology as really kind of high potential areas as having hard cores. And then I pointed out how stone artifact analysis is way out there, have lost cores at the moment at least. So, and I said that what we need to do, we've got these areas of archaeology, we just need to identify what their needs are really, or where the most transformative application can be. And then we'll get a really meaningful engagement with technology in archaeology. And And so then I followed up to answer that question with this notion of, to answer that, where can we get transformative change? So let's say, okay, we've identified the zooarchaeologists and geoarchaeologists as our target audience. What are we going to do to them that is really going to transform the way they work? And I've said that, these notions of ideas of enhancing reproducibility and the sort of software tooling that has emerged in other areas of science that seems to do that very efficiently. Those are the things, we just take those, apply those to the zooarchaeologists, and archaeology will be unrecognizable. So that's the answer to that. Is I think the sort of technologies of reproducibility are where we're likely to find the most transformative potential in archaeological practice. So what are there are many challenges with reproducibility. I would hardly say that it's just a sort of out-of-the-box thing that we could all just go home and do tonight. It's still a learning curve. And I think the implications for us are just going to focus on a specific implication in this context, as a faculty member, and I know there are a few other faculty members here, and as a graduate student, and I can see some of you there, what should we do? How should we think about this? How should we change the way we behave at the moment? So the implication is that this is how we work in a sort of traditional way, that for faculty, the way most of us were raised. We started out with a breadth of knowledge from our undergraduate training, and then we more or less sort of fell down a hole of specialisms, or our dissertation specialism. Traditional researchers, T-shaped. Know a little bit about everything, but a lot about the specialization. And I think the implication of the potential that reproducibility has, and I'm sure many of you are aware of so-called reproducibility crisis in many disciplines, such as social psychology and economics. The implication is that as faculty, we need to be preparing ourselves and our graduate students with this kind of second leg in their graduate training. So they get their domain specialty as they would anyway, and then we need to be equipping them with this, what I'm sure many of you recognize as data science, the sort of skills and theory of data science, and I'm calling it here specifically reproducibility and computing skills. So we need to incorporate this into our graduate training and make sure we have sort of opportunities for our students to acquire these skills and explore them and integrate them into their domain work. And as students, I think you need to demand this of your programs. You need to say to your faculty and program organizers, say, if I'm to be competitive and productive as an archaeologist, I need to have opportunities to develop these skills. And some of you may know that at the University of Washington, where I am, and Berkeley and NYU, we're part of a sort of a syndicate, a data science consortium that's funded by the Moore Sloan group. And we have these programs where graduate students are getting sort of a kind of broad spectrum data science training that's fairly not specific to any particular discipline, but aimed to be applicable throughout any kind of field. And I think Berkeley are currently most advanced in sort of data science requirements for undergraduates and courses for graduate students. So if you don't have those available, and you're a student, you should demand something like that is going to equip you with these skills to be part of the transformation, I think, that is going to happen in archaeology that relates to openness and reproducibility in the way that we've seen already, I think, in some other disciplines as well. So this is kind of a very concrete kind of recommendation that I have. As faculty, we need to prepare our students for these skills and tools, and as students, you need to be demanding this of your programs, so that we can sort of continue the momentum of this transformation. Thank you very much.
Thank you very much, Ben. I'm going to take over the mic here, and because we have some beer and wine out in the hallway, and I'm sure there are lots of questions. I have lots of questions for you, but I don't want to take away from our time for casual conversation over alcohol to conversation here. I did want to say a couple things. I wanted to thank Ben very much for this very stimulating talk. Mention that we do cover Lakatosh in our theory seminar, which you might like, and also thank you for plugging all of our graduate students' papers. I don't know if you knew you were doing this, but all the papers you put up on it's too bad that it was strategic. It would have been nice if they had just risen to the top. Anyway, there's a lot here that relates to all the talks that we had today. I wanted to plug one other thing, which is that we have a seminar in April 27th and 28th, about the uses of drones and spatial analysis. The the CGA is hosting. Jason wanted me to remind you of that in case you are around and are interested. Welcome you out to the hallway to continue the conversation that's been stimulated by Ben's marvelous talk, and thank all the participants